So I'm Chris Bregler. I'm running a research team at Google, and we're looking into synthetic media in general. And right now I want to talk about deepfakes and cheapfakes, and I will define also what we mean with cheapfakes in a few minutes. But this is about the deepfakes session. So deepfakes, as you know, is creating synthetic images of faces or sound or other things, and then make people say things they never said before or be at places they haven't been before. And before I actually joined Google, I was working in the visual effects industry, and that was the main goal in visual effects, to create people to do things they haven't done. You see here, I worked for Industrial Light and Magic, and we have here like a tradition of over like 20 years of doing stunts, and a stunt double is performing something that is too dangerous for the actor. And then with visual effects, the photorealistic face of the actor gets swapped in, or the latest Star Wars movies where an entire character, like here Tarkin, was built from the ground up. And so all this is not done automatically with some piece of software. This is done by a large team of visual effects artists and motion capture supervisors and researchers. And every second in the movie is many hours or many weeks of work to tweak and get this really right. And usually the software is not available outside visual effects studios. Now, over the last few years, as you might have seen, there have been also several university projects and also startups that do this fully automatic. And this is not an exhaustive list of systems here. There's even one system by University of Munich by Justus Thies that will come out soon, but it's using deep learning or shallow learning, if you want to call it like that, to make a person say things they never said before, or swapping out faces. But also these are research prototypes, and usually only graduate students in the university labs can run it. Or in case of Synthesia or other startups, it's proprietary software, and it's used in a controlled fashion. Not everybody in the world can use it. But then, that's the name for this session, deepfakes. Over 2 years ago, an anonymous user on Reddit called Deepfakes published a new technique that can swap out faces in videos. And so here you see an original video of Amy Adams swapped out with like Nicolas Cage. The first public code, open source code on GitHub, was published a little bit over 2 years ago. And then since then, every few weeks or even every few days, new techniques come out, or new small modifications of those deepfake techniques come out. Now, usually you have to be a software engineer and compile that software, and you have to have a high-end GPU card. But also we've seen over the last few years, websites coming out, deepfakes as a service. For example, if you want to pay like 5,000 yens, somebody else can do it for you. And recently also new mobile apps came out. They can do it in a specific way, in a restricted domain. But still, it needs to be very carefully crafted, the training data. And often the deepfakes don't look very good. It sort of like requires some talented machine learning experts to run those things. Now, given this, that over the last 2 years, you see this open source software widely distributed, and many hobbyists are using this now for fun. There have been also some malicious uses, and there has been a lot of press and congressional hearings and a very public debate about the harms that can be potentially done to society. And so our team at Google and many other teams at other universities and companies, we were also looking at mitigation techniques. So the research community that generate synthetic media is very active, but also the research community that does detection become more and more active. And usually there are like 3 steps involved. We're like started looking at all kinds of different generation architectures that we see in the public domain. Then you create data sets, and then you can start so-called detectors that can distinguish if an image is fake or real, or if certain pixels are fake or real. So if you look at the last 1.5 years of development in the GitHub space, the open source space, you see a lot of progress has been done. And here's one example. This is Nick Dufour on the input video. He's our lead engineer on the team. And he paired up with another person in our lab to face swap this into a person that doesn't exist. And if you use the best techniques 1 year ago to do this in the best public available techniques to deepfake this, you get something that is pretty convincing, but it's still very easy to detect. There are a few like little flickers. I'm not sure if you see this in the video conference app or like some blurriness is happening. But then the most recent deepfake techniques that are out in the open source, it's much higher resolution and less flicker and so on. So the technology moves fast. So having seen this, what we've done just a couple of months ago is we published some of the deepfake data sets that we created with those public domain techniques. And we partnered up with 2 leading universities that have been also doing deepfake detection technology. This is one university is at University of Naples by Professor Luisa Verdoliva, and the other one is at University of Munich, led by Professor Matthias Niesner. And they have been already over a year been publishing deepfake data sets, so-called the face forensics benchmark, and asked many other academics to submit detection algorithms. And there's a leaderboard that then ranks what sort of is the best or the second best detection technique out there in the research community. So all these spaces here, we published them. They're all fake. And I'm not going into the details here, but we applied 15 different architectures with over 100 different parameters, like very high resolution source video 4K, with Jigsaw in New York City. Jigsaw is another unit at Google that deals with misinformation for several years. And then these actors consented to be deepfaked. And then once we publish them, you can have that from the face forensics website. That's the last bullet point here. At the University of Munich, we're basically supporting with this data set many benchmarks out there. You can use this for your own research, and over 1,000 groups and people have downloaded that since our release in September. And there's also a leaderboard online. And I want to just show you a few examples here. One of this is fake and one is real. And this is the original video. This is on a street in New York using this actors that consented to be deepfaked. This is fake, this is real. This is fake. One of those is fake. This person is fake, and so on. So you can go online and see that. And there's several other benchmarks out there and other data sets as well. And people are mix and matching these training data sets right now. Now, also, we didn't stop just with images and videos. Over a year ago, we already published so-called audio deepfakes. That's also an important task. Daisy Stanton from Google was leading that effort. And many other companies and groups were publishing audio deepfakes. And there's, like with the face forensic, there's another academic-led benchmark that meets every year. And the last time they met was in September at the main speech conference. And there is a challenge that's called automatic speaker verification that has now also a challenge where you want to train techniques that can detect if something is fake or something is real, just using audio. Now, this is deepfakes. And as I said, I also want to talk about another threat in the landscape of visual disinformation, so-called cheapfakes. So cheapfakes have been around for a really long time, longer than the last 2 years. And cheapfakes come from the observation that it's much cheaper to do them. Here's one example from many years ago where somebody just cut and paste one of the rockets and one of them is fake and use that for some disinformation campaign. Now, cheapfakes, some of the cheapfake techniques are so-called Photoshop manipulations. They have been around for over 100 years. Right now, it's, I think, the 30-year anniversary of Adobe Photoshop. So for 30 years, it has been put in the hands of the everyday user to do those. And you see here some images that even like publishers like the LA Times and others were published, and they didn't actually during the time when they published figured out that this was a photoshopped image. Now, like with deepfake detection, here's one of the examples that happened 2 years ago. This is Emma Gonzalez from the Parkland shooting, and she took this photo where she rips up a Target to protest against gun violence, and then somebody photoshopped the US Constitution in it. And this was used in a disinformation campaign. Now, if you ask, again, one of the leading universities in this space, by Luisa Redoliver, they have a technique called splice detector that can automatically detect that there are some pixels that are most likely fake, and on the real images, it triggers much less. So over a year ago, we started another experiment in this space, and this was led by Jigsaw. That's a unit at Google, as I said, who has for several years been looking into misinformation together with us and with a few leading universities like University of Maryland, University of Naples, and 2 teams at UC Berkeley. We put together their state-of-the-art Photoshop detectors. And in this experiment, we tried how that can be used by fact checkers and news organizations. This is a closed experiment. This is just whitelisted participants. This is not a public portal where everybody can use it. And just a few weeks ago, Jigsaw and us were publishing some findings on this. And here you see some example. This is running a photo that has a fake shark. And a journalist or fact checker can use this user interface right now and uploads that image and then run all the detectors or a combined detector, so-called a sample model. And here you see the output of JPEG dimples that is from Hani Farid's team at UC Berkeley that marks that the shark is fake and everything else is less likely fake. So, but this is not a silver bullet. This works. Sometimes this doesn't work, some other times. So this is just one out of many tools that can be used by fact checkers and journalists to look if certain media is fake or real. Now, cheapfakes, as I said, happens much more often than deepfakes currently, but we have to take deepfakes very serious. And another disinformation, visual disinformation case that happens even more often is so-called misleading context. Like somebody doesn't even change an image, doesn't use Photoshop or deepfake. It just uses they use an original image and then write another story about it that puts it into the wrong context. You see here an example on social media that was shared and claims that there's a demonstration in Turkey, but if you run Google's reverse image search, you quickly find out that this is actually an image that is reused from Morocco, where there was another demonstration. And it claims it's from Turkey, but you can determine with all kinds of other tools that this was used out of context. Now, if you look at all those, there, as I said before, deepfakes, cheapfakes, misleading context, these are like the sort of the broadest categories in visual misinformation. But there's also another threat, and we call that the liar's dividend, where an image or video is not fake at all, but people claim it is fake. And this was by Bobby Chesney and Danielle Citron at some interesting publication, coined this term, the liar's dividend, and this happens frequently. Here's one example where in a Brazilian election, the former mayor of Sao Paulo, who was running for governor, had like a few days before the election, some video has been shared showing him in some controversial activity. And nobody could determine that this is actually fake, but his supporters claimed this is a deep fake. And this happens in many, many other areas over the last few years now. Having the knowledge that there is this possibility to create a deep fake, but you don't even have to create a deep fake. You just like claim now, this is not real, this is a deep fake. Okay, so as I said, this is just one mitigation technique to run detection, but there are many other mitigation techniques that we and the community look into, like provenance, digital signatures. We're working with psychologists, social scientists, policy, and many others. And I just want to conclude, this is an arms race. The synthesis techniques are improving over the years, but also the detection techniques are improving over the years. And this, the problem of visual misinformation is nothing new. It happened already over 100 years ago, right after the invention of the camera. And we do not have, there is no silver bullet. We cannot just like have detection algorithms or provenance algorithms or many other things. It's a complex problem that has been around actually since we invented human language 50,000 years ago, and we invented the first rumor and figured out rumors are spreading faster than like true statements. So that's basically a survey what we're doing in various different visual domains and how we work with different universities and organizations. And that basically concludes my talk.